Good morning everyone, my name is Nafingatun Ngaliah and my friend who will present our research, namely Mutia Rahmi Dewi. The lecturer who supervised us was Mrs. Siti Rochimah. I thank you for the opportunity you have been given so that we can share the result of our research. Our research is Maintainability measurement and evaluation of myITS mobile application using ISO 25010 quality standard. We will explain this presentation in 4 outlines, namely an introduction, method, result and discussion, and a conclusion.
Academic information system has become a mandatory application for some colleges nowadays, especially in Institut Teknologi Sepuluh Nopember, namely myITS, which is used by lecturers, students, and education staff. In myITS, there are several information systems that can be accessed, including academic information system, scholarship information systems, camp information system, and curriculum information system, or we call FRS. FRS module is the most important module for students in taking courses every term. Besides, FRS module is also used by lecturers who act as academic advisor to approve courses taken by their students. At the beginning of the academic year before college starts, almost 16,000 students access FRS module to take course. Low performance of the system often happens. The quality needs to be concerned, such as the module is secure, usable, and suitable with all determined requirements. A system which already considered has good quality often still appears bugs, errors, and poor performance. Why? Because it needs to improve the quality of the software. By improve the quality, FRS will have better performance. That's why, in the study, we propose quality measurement of myITS mobile application based on maintainability to evaluate FRS module as a reference in the next development.
In this process of measuring maintainability, we propose a method which we then describe in the following diagram. The first stage is the analysis program. In this stage, a reverse engineering process is carried out to analyze the source code of the myITS academic information system. Apart from analyzing the source code, this process also converts the source code into class diagram to get the design of myITS system. In general, the system design in myITS development uses the MVP architecture, model, view, and presenter. From this process, we get several parameters that are used to test the quality of the myITS application. After getting the software quality test parameters, then we enter this parameter into software quality calculation. The quality standard we use is ISO 25010. Maintainability measurement with the ISO 25010 standard are divided into 5 sub-qualities, namely modularity, reusability, analyzability, testability, and modifiability. Modularity is a quality that can be used to measure how far the change of a component in a system only have a small effect to other components. And then reusability is a quality that can be used to measure the ability of a system to be reused on a different system. And then analyzability is a quality that can be used to measure how far a system can be analyzed, in this case diagnosing deficiencies and failures of products that can occur or identifying parts that are modified. And then testability is a quality that can be used to measure the ability of a system can be tested. And then modifiability is a quality that can be used to measure how far a product or system can be effectively and efficiently modified without any defect or reduce the quality of existing products. This study, maintainability, is measured in sub-quality modularity, reusability, analyzability, and testability. Sub-quality modifiability is not included in the focus of the study. This is because the measurement of modifiability needs a lot of effort and resource. The measurement of modifiability capabilities also requires some skilled programming language developers. After determining the quality parameters, we calculate the FRS module maintenance measurement in myITS application according to ISO 25010. The quality measurement were carried out on the sub-quality description of the maintenance measurements. The purpose of measuring quality is to get the quality value X. Before getting value X, the required variable values A and B are calculated using the formula. Values A and B can be found with the help of important values as specified. The specific formula for each sub-quality is contained in the ISO 25010 document, which can be accessed online through the ISO website. The formula for each sub-quality is not included in this paper because the information is not public. This is an example of quality test for modularity. The formula is used to calculate the component suitability coupling by dividing variable A, which represents the number of classes that do not have a class dependent on that class, by variable B, which represents the number of classes that have transaction with the database. The result of division is expressed as variable X. At the final, an analysis of the result of the measurement of maintainability and evaluation is carried out. The result of the analysis and evaluation can be used for further application development. It also can be used as a reference in making similar application. To get the result of the analysis, we use key performance indicator weight with analytical hierarchy process method. In this method, we do a weighting for each point on the sub-quality of maintainability, so we can determine the quality of FRS module on myITS application.
The data set that we use in this study are source code from FRS module in myITS student and lecture. We get the data set from Directorate of Technology and Information System in our college. These are tools we use in maintainability measurement. In every tool, we give code by alphabet to make easier in inform the result. Here's the program analysis result based on refactoring engineer. We get 5 classes or interfaces of each package and more than 74 total number of methods. Here's the result of maintainability measurement. In coupling of component conformance point, myITS student get higher score than myITS lecturer. It means class in myITS student is more independent than the class in myITS lecturer. myITS lecturer has higher conformance to coding rule than myITS student. This is because class in myITS lecture doesn't have a mistake at all after checking the style of the source code. All of features of myITS lecture are available in the program, in the definition of program requirements, and implemented in the program. That's why myITS lecture has higher value in diagnosis, function effectiveness, and sufficiency conformance point. In testability points, both of them has the same score. To analyze and evaluate the measurements result, we use key performance indicator weighting as follows. Its quality has weight as 1. So every point of sub-quality has weight equals to sub-quality's weight divided by total point of sub-quality. For example, modularity has 2 points. So each of points in modularity has weight 0.5. Whereas points score we get from maintainability result on the previous slide. Sub-qualities result we get from points with time point score. Based on key performance indicator weighting, we get project score, or we can call the application scores as follows. To get the quality of both application, we categorize the range score. Based on that, both of the application have good quality.
After performing calculation with this method, we can quote that the FRS module in myITS application has good maintainability, but needs to improve the sub-quality of reusability and testability, especially in accordance with the coding rule point for myITS student and the autonomous testability point for the two projects, myITS students and myITS lecturer.
That's all about our presentation, and thank you so much for your watching, and see you!